Hello, my fellow mathletes, and welcome back. We're looking at question number 10 as we continue part one of our 2010-2011 math contest. We are constructing isosceles, but not equilateral triangles, so there'll be two sides that are the same and then one side different. With positive areas, I guess they don't want us counting like 10 and 5, 5. That shouldn't count as an isosceles triangle because it has a zero area. That's what we call a degenerate triangle. I'm surprised they even bothered mentioning it, but okay. Okay, positive areas and integer side lengths between 1 and 9 inclusive. So 5, 5, 10 wouldn't have worked anyway, but 4, 4, 8, that sort of a thing. So integer side lengths between 1 and 9. The number of such triangles which are non-congruent is. So non-congruent, not non-similar. So I can have 4, 4, 2, and I can still have 2, 2, 1. An interesting question if they had said non-similar would have been more work for us, but okay, so non-congruent. How are we going to do this? Well, we only have the lengths 1 and 9 to work with. Now, if I imagine an isosceles triangle with sides, it will have A be the duplicated side. So A is not B. Okay. Then the triangle inequality steps in and tells us some nice things. So any one side has to be smaller than the sum of the other two sides. This is what's known as the triangle inequality. Okay. But of course, as long as B is positive, and since B will always be at least 1, this one's satisfied, but the more interesting one will be this B side has to be less than the A plus A, or 2A. Okay? So B has to be less than 2A. So what we could do, I guess, is say, all right, could A be 1? Could B be, and so on. And as long as this condition is satisfied, we should be able to make an isosceles triangle. So A could be 1, in which case 2A is actually I think I'd rather make this chart vertical. We'll put A, we'll put 2A, and then the values that B could be. So if it's 1, then you get 2 times 1. B could be 1, but we're not allowed to have the same thing as A. So sadly, that's not going to work. A could be 2, and then you get 4. Now B could be 1, 2, or 3. It can't be 4, but it can't be 2, because A was already 2. But you can get 2, 2, 1, or you can have sort of a fatter one, 2, 2, 3. Okay, so these are making sense to us. So 3, 4, 5, 6, 7, 8, and 9. So 6, 8, 10, just filling in the values for 2A. Okay. And then what can B be? So 1, 2, 3, 4, 5, but not actually 3. 1, 2, 3, 4, 5, 6, 7 is less than 8, but it can't be 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, but it can't actually be 5. And you might say, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and you can't be 6. But remember, B has to be one of the single digits, just like A does. So we don't even bother writing the 10 and 11s. And so all 9 numbers, 1, 2, 3, all the way up to 9, are less than these remaining ones. So you always get all these numbers. Okay, but we throw out the 7, we throw out the 8, throw out the 9. Okay? So how many triangles do we get? Well, when A is 2, you get 2 triangles. When B is 3, you can get 4, and then 6, and then from then on out, it's 8. Okay? And just if we're worrying about non-congruent, because we don't have equilateral triangles, the A is being duplicated twice and the B isn't. So all of these give us a nice, you might say, oh, 2 and 3, aren't you getting the same triangle? Well, no. 2, 2, 3. So aren't you getting the same triangles down here? No, because that's 3, 3, 2. Okay, so we're perfectly fine that way. So 2 plus 4 plus 6 is 12, plus 8 is 20, 36, and then 52. So 52 triangles are available to us. 52 isosceles triangles, and that's right in the middle. That's an answer of C. And there we go. So up next is, what was it, question 12? No, question 11. So up next, question 11. Take a nice short break, and I'll see you for more math in the next video.